Okay, everybody, let's jump into this so that you have time. You know the short day. I want to try to give you time to work on your homework in class because I always like to have that for you. Okay, so next unit, jumping into things. What we're going to be learning about in this unit, the big thing of today is we're going to be learning about this unit called a mole, which some of you I think are somewhat familiar with, maybe you're not. Sometimes it gets introduced in like junior high, but not all the texts. So it could be new or maybe somewhat familiar. But the mole is like a critical word in chemistry. It's very unique. Like chemistry has a very unique vocabulary. It obviously applies to other things outside of chemistry, but it's used primarily in chemistry. And so we need to really understand what this is because it's going to help us in solving complex problems. Okay? To start off today, though, we are going to do kind of like, it's a little bit of a pre-thing of teaching you a skill of conversions. Now, once again, you may be familiar with this, you may not be, so either way, hopefully it's a good review or we're going to teach you how to do it. But think of it as I'm teaching you a skill that's going to be applied not only to this unit, but like 3 other units this year. Now, with this skill, and I don't do this often, but you have to write down all work for this unit if you want credit on your homework. And your work has to follow the format I'm teaching you. When it comes to the quiz, if you feel like I've got it and I don't need to write work, then that's up to you to decide. But in order for me to help you as a teacher, I need to see that thought process along the way so I know if you do get things wrong, where we're struggling. So for those of you that don't love showing your work, I'm sorry, but I guess I'm really not sorry either because I know it's going to help you, okay? So that's what we're going to do with these first units. Now, if you look at these different units, some of them you should be familiar with, right? Like a gallon, inches, what are those? A yard, right? But then other units, maybe you aren't as used to hearing, right? Like a dram as a unit of measurement, right? A peck as a unit of measurement. But the reason why we bring those in is just to recognize, once again, that there's a lot of different types of units, but the way you use them are all the same, okay? So for this first section of notes, it got something a little mixed up in getting these copies. So you're going to do the first section just on this blank page right here. We're just going to do some practice problems with these, and I'll show you how you're going to use them here in a second, okay? This little thing is going to be your road map. Now, it folds out depending on how many steps you need, okay? So the side width, there should be like a square. That's like the starting side, so put that to the left. And then if you only needed one step, you can kind of like fold back the other ones if you want. You could just keep them all out. But then every time you need another step, we're going to add to our conversion map. Okay? All right, so kind of lay that out with that square on the left side. Okay? So when we solve conversions, okay, there's a pattern to it, and if you follow this pattern, every problem we do is going to feel the same, even though it's technically different. The biggest thing that's kind of interesting is when you are converting units, you're not actually changing the value of it. You're just changing how it's being represented. For example, I could measure something and say that this width is the length of 1 foot. But I could also say this is a length of 12 inches. Now, 12 does not equal 1, but when you add the unit with it, they are now equal. And that's the whole thing with this whole long conversion map, is technically the end thing equals the beginning thing. It's just now represented in a different type of unit depending on what we're trying to look at, okay? All right, so the first problem here is, okay, it says how many paces are there in 19 yards? Now the first thing you want to do, write this question down so you have it as a reference on top of your research. Don't worry, you won't have to do like tons of like fill in your own blank stuff. So write that question down. How many paces are there in 19 yards? All right, whenever you problem solve, and I recommend this not just in this class, but like anytime you're in class and you're trying to problem solve something, the best thing to do is identify what is it I'm trying to find and what is it that I know, because that gives you a framework of like, I'm starting here, I'm ending here, now we just have to fill in the between. Okay, so what is it this question wants me to find? Paces. Thanks, Lincoln. Everyone circle the word paces. I always circle in a problem, what am I trying to find, so that I kind of have that direction of where I'm going, right? Okay, what is it that I know about this problem?
19 yards.
Good, Tate. So we have 19 yards. So I would underline that. So I'm in the unit of yard, but I want to get to the unit of paces. Well, once you have circled and underlined, the first thing that you do is start with what you have underlined, because you have to start with what you know. So I'm going to start by putting 19 yards at the beginning. I'm actually going to bring this up here instead. Okay? So that's why the first spot on your map is just a square. It's because we don't start with a fraction. The fractions are used to convert things, but the first thing you write is just what you're starting with. So that's why it's just a square and not a fraction. Okay? All right, now what we need is eventually we're trying to get to paces. So I want to change out of yards and get into paces. So these fractions are a way of doing that. Now the way the pattern always works is whatever unit is here has to be the unit that goes on the bottom every single time. If you think of it mathematically, when you divide something by itself, what do you get? 1. So in a sense it goes away. So I'm going to put yards on the bottom. Now notice I haven't worried about a number yet. The units will guide your work. So pay attention, do the units first, and then take care of the numbers. Okay, now the thing that goes on top of the fraction needs to be something that yards connects to. So if I look up at, this is a big conversion box of telling me different connections. Does anybody see, is there a connection directly between yard and paces?
No, but there is.
Okay, good. So I can't go straight to paces because I don't know that relationship, right? But a lot of you identified, well, yard goes into inches, and why does that help me out?
Because after you convert to inches, you can
Because then if everyone sees up there, inches then will connect to pace. So that's where this could be a one-step problem if they connect directly, but you may have to make multiple connections. All right, I'm going to keep building my map, and then I'll come back for the numbers. So then I'm going from yard to inches, and then when am I going to go next?
inches to paces.
Perfect. So then I'm going to go from inches. Sorry, I meant to make these different colors to help emphasize it, but I didn't have that many colored papers, so pace is also green. I recognize it's a different thing. Okay. So all my units are set up. Once again, notice, diagonal cancel, diagonal cancel. The only thing left is what I circled. Once that's the case, then you're done. Now, what connects these two things together? Right. It says 1 yard equals 36 inches. These two things are equivalent. Right? That's the only way this works, is literally you're timesing this by 1 over and over and over again. But the units are constantly changing, and the numbers are changing to make it balanced. Okay? What connects these two?
30 inches.
1 pace equals 30 inches. And now I'll let my calculator do the work. Okay, questions on the setup before we type it in? Okay, the way I would type this into my calculator, you could type them in as actual fractions, right? So you do 19 times 36 over 1 times 1 over 30, like as a fraction inside parentheses. When you have a lot of number ones, I simplify what I type in my calculator. So what I would type in my calculator is don't lose the beginning. So I would type 19. 36 is on top of the fraction, which means it's multiplying, so I times by 36. Ones do nothing mathematically, so I'm going to ignore it. Ignore. This 30 is on the bottom, so I'm going to divide by it. And then hit equals. Which is just a little simpler than typing in fractions in parentheses. Yeah, so things on the bottom divide, numbers on the top multiply, and if it's the number 1, ignore it. Somebody, I didn't even plug this in. Does someone have the answer? 22, is that here? 22.8. And then, all answers need a label. What have we changed it into? Perfect. Good. Okay, questions so far? Okay, I'm going to pull up another one, and what I want you to do with your little pieces and your math, with your table buddy, is see if you can build out the pathway you would take. So I can kind of see how we're grasping this so far, okay? Okay, we want to convert 4 quarters to cloves.
Not there. Yeah, but it's.
Okay, so I should see. So just because it'll help me visually build it on here.
We don't have cloves or quarters.
Well, that was a great example, wasn't it? What
Yeah,
the?
we don't do them.
Yeah.
Okay, well, never mind. Do it on your paper, and I'll look at your papers. And maybe we'll build the next one. Shoot, my TMS said those must have been like the last on their list of cutting. Once again, just start with the units, figure out here's where I'm starting, here's where I'm ending, what pieces are going to connect me to get there. Yeah, so we're just doing like some free problems. You may have learned how to do conversion before, maybe not. Yes, yeah, once you get there. So we're just doing these problems. So, the basic idea, if you look up anything up top, is we're just changing, so we're in the unit of quarters, and we're trying to get to the unit of cloves. If you look through that list, there's no direct connection between the two. So you've got to see, it's kind of like well, this connects to this will connect to this, until you can get to it. So the way that it always works, can I steal yours for 1 second? So you always start like this. Okay, this is what I'm starting with. Then you set up the two things that relate. And the pattern always goes that what you're trying to get out of is here. And what you're going into goes in. And then I want to go out of inches and into quarters. So you should always have this diagonal canceling idea throughout the whole thing until you get to the final.
12 goes in pounds.
So I'm in this, I want to get out of yards in inches. I want to get out of inches, and then technically if there's more, does that make sense? Okay. Yeah. Technically, we aren't going to do, your quiz aren't going to have these type of ones because they're going to be chemistry related, but yes, like you don't have to memorize those. Okay, set your pencil on your paper if you're done. That way I just know you're not thinking still. And I'll just kind of glance real quick. No, because you can always go, so you're in pounds, right? So put pounds on the bottom, you always want that diagonal, and then close on top. Oh my gosh, right there.
How do I get the words?
Because just like you can say 1 foot is 12 inches, you can also say 12 inches is 1 foot. Yep, so it goes both directions. Perfect, now plug in your numbers. All right, how are we doing on this row here? Feeling pretty pro? No, you're doing great. That's good.
No.
Sounds like a what? Yeah. Wait, is it coffee? Oh my god. I can't. You don't say anything.
That right here, that there is a pound.
I've actually got it. What was the one I said yesterday? Hold up.
It's $16.
What is that? I don't even want to know that conversation. Okay.
Oh, there it is.
I'll be boy.
So they do carry water. No one's ever not there. Gavin, fire.
Drink off is better than
No, I know what it is. I know what the answer is.
Okay, if you have 16 cloves, have a smiley face real quick. Oh, I need to pass this back.
Also, on another note,
Okay, any questions so far? like we're doing pretty good. Let's do one more for good measure, and then we'll get into the chemistry unit. Now, Katie asked a great question. I do want to emphasize here. If I were going to ask you to do something like this on the test or quiz, I would give you all those conversions. Right? That's not what this is about. This is about knowing how to convert given the units, right? Because we live in a time where you don't need to memorize things. Right? You could look up a conversion, but you may not be able to find the direct relationship of how it converts. Okay? All right, let's do one more for smiley face, and then we'll transition into chemistry, how this relates to the chemistry stuff. Okay, let's do this one. How many nails are in 31 yards? How many nails are in 31 yards? Okay, Jamie, how can I help you so you can practice with this? It's not, it's chemistry.
Nobody has
The
to
maximum is multiplying your
The calculator does
Okay.
all the math.
That's math. Literally back off. I'm done.
Do we have all the pieces to build this one?
nail is 2.5 inches.
Think you on it? Okay, try this.
Why?
Nails, 31 nails.
Wait, we're doing that? I'm so no, we're not. Where did you get quarters from?
I don't know.
So then where, or,
Did it actually? No, the 16 was for the globe and the 4 quarts one. Plural, the plural, it's a quarts, and the plural of quarts is not quarters. Beaver!
So there is a unit called a quarter.
wait.
Beaver over here.
Wait.
Oh.
One nail is
Okay, you know what, mine's gonna say quarts. I literally legitimately thought it said quarters.
Yeah, you have the right logic, but not the one.
A fifth year.
Okay, that's what. Okay, that's what you don't want on the bottom. But this is then. Starting from whatever unit is here.
I know I do, and I owe the bottom.
Like you want to divide by it to get rid of it. So flip your back. You have all the right things, but now they're just all. Yeah, you just need to flip that first. I think.
It was just like, I don't know, man. We have no idea. I think we have 3 times.
It's like this is
Stop.
Okay, just because, okay, everyone, put your pencil down once again if you're done and have an answer. That way I know you're good. You didn't even realize it?
What guy even quote?
You said, I am good.
What?
You said, I am good. Okay, if you have 496 nails as your answer, you can have another smiley face. Okay, any questions yet? Now, I do want to bring up a common mistake that happens.
How do I already have that?
Go to inches. Okay. So, give me your attention here, everybody. Let's put those cell phones back away. Right. Cell phones are great, but they really disrupt that brain from like processing things, right? Okay. So, as you're following the pattern, right? The pattern's always the same. Whatever's here must go here every single time. And then the numbers that get put in here are what make these two things equal. Okay? Don't get so lost up in the pattern that you forget to think about it logically and do something that I often see students do where they have this set up, but then they do this. Right? But if you think about that logically, you should be able to say, hold up, right? 1 inch does not equal 36 yards, right? You should always be able to change this into an equal sentence. Like, this equals this. If you can't do that, then you're just making stuff up and you can't go that way, okay? All right, so what we're going to learn about now is the same thing. It's just a different type of unit. Okay, the type of unit we're going to learn about here is known as the mole. So go ahead and you can flip your notes over to now where the notes are. We'll fill this in.
It's gonna be like your
So just like you maybe never had heard of quarters as a unit of measurement before, the mole is just also a unit of measurement. It has a value. Okay. Now, it's particular to chemistry, and we'll see why in a minute. But a mole, particularly, is a counting unit. Okay? It's a counting unit. So, like inches, what type of unit is inches? Like length, right? It measures length. If it's pounds, what are we measuring?
Weight.
Weight, right? Or mass. If it's a mole, we're measuring counting, just like a dozen. Right? A dozen is a counting unit. If I have 1 dozen of scissors, how many scissors do I have?
12.
12. If I have a dozen markers, how many markers do I have?
12.
Right? If I have a dozen
Bakers.
hand sanitizers, how many do I have? 12. Right? Okay? It doesn't matter what you have. A dozen is always 12 of that thing. A mole is the same idea. The difference is that if I have 1 mole of something, it is 6.02 times 10 to the 23rd of that thing. So it's a very, 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 very big counting number. Okay? So if I have a mole of markers, how many markers do I have? A lot. I have this many markers, right? If I have a mole of pens, how many pens do I have? This many pens. Now, I want to point out something as we are using the mole a lot in this unit. Okay. So this little block right here is 1 mole of aluminum atoms melted together. Okay, 1 mole of aluminum atoms. So what does that mean? How many aluminum atoms are in this block?
6.02 times 10 to the 23rd.
Good, 6.02 times 10 to the 23rd. Okay, this is a mole of salt. NaCl is its chemical formula. So there are 6.02 times 10 to the 23rd NaCls in this container. Okay, this is a mole of sugar. Why are they not all the same size?
Because that is the same.
Right, it's just a counting number, right? Just like if I had a dozen mice and a dozen elephants, right? They're going to be different sizes. They're going to have different mass. Same thing here, right? So I heard someone say, let's emphasize again, why is this one why is it so much bigger? What does that tell me about the molecule?
It's bigger.
Yeah, and you can see from its formula, it's a really big molecule. So if you have that many of them, it's going to take up a lot more space and mass than just Al by itself, right? Okay, now, why is the mole such a big number? Why did scientists come up, when grouping these and counting these, why so big when we're dealing with atoms?
There's a lot of them.
Yeah, they're so small, right? If it was anything else, it isn't something tangible to us. So that is the point of the mole. The mole is what bridges the gap between what you can't see and what you can. I can't see an atom. I can't measure out an atom. But I can measure out a mole of atoms. I can work with a mole of atoms in the lab, and they connect to each other through that relationship. Okay? Okay, so let's try.
Wait, what was that?
Oh, we'll watch. Yeah, we'll watch this one. This just gives you some analogies of the mole, of like how big of a number it truly is.
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your ant's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe, or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you had equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amadeo Carlo Avogadro. Wonder how long it took him to sign autographs. Fortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists looked at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Unfortunately, Avogadro died in 1856. Now the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it particles of gas in a container. Or in scientific notation, 6.02 times 10 to the 23rd particles. This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind. Avogadro was the first one to come up with this idea. Scientists named the number 6.02 times 10 to the 23rd after him. It is simply known as Avogadro's number. Now, back to the mole. Not that mole. This mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles are hard for students to understand because they have a hard time picturing the size of a mole, or 602 sectillions. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? Maybe this will help. Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank. Okay, now we sort of have an idea how large the mole is. So how do we use it? You might be surprised to know that chemists use it the same way you use pounds to buy grapes, deli meat, or eggs. When you go to the grocery store, you don't go to the deli counter and ask for 43 slices of salami. You buy your salami by the pound. When you buy your eggs, you buy a dozen eggs. When we hear the word dozen, we probably think of the number 12. We also know that a pear is 2, a baker's dozen is 13, a gross is 144, and a ream of paper is, anybody?
Nope.
A ream is 500. Well, a mole is really the same thing. For a chemist, a mole conjures up the number 6.02 times 10 to the 23rd, not a fuzzy little animal. The only difference is that the other quantities are more familiar to us. So there you have it, the story of the mole, Avogadro, basketballs, and how to buy salami at the grocery store.
Okay, so a mole, once again, is just a really, really, really big number because atoms are so small, right? But it's just a way for us to group them in a way that I can measure them in the lab, I can actually see them, but it's proportionate to what is happening on the atom to atom level, okay? Okay, we're gonna skip this here and let's go to that first practice problem. Okay, so the relationship we're gonna build today is the connection between mole and particle. Okay, that if I have 1 mole of something, how many particles do I have? 6.02 times 10 to the 23rd. Okay, now this word particles can mean a lot of different things in chemistry. Okay, it could mean atoms, it can mean formula units, it can mean electrons, it can mean molecules, it can mean ions. So if you see any of those words in the problem, it just means a type of particle. Okay, so there's a few blanks to fill those in, so fill those in real quick so that if you see them, you know, oh, this just means particle. Sorry, did everyone get that? Okay, good? All right, so let's do the first one. What is the bachelor's? Let's do the one that's on your paper. I don't know why it doesn't match that.
Right there.
We're just gonna turn this off and do the one on your paper. Okay, so read the question, circle what are you trying to find, and underline what you know. So reading the question, circle what are you trying to find, and underline what do you know. All right, if you physically circled the word molecule, have a smiley face.
Yay.
And if you underline 2.5 moles, have a second smiley face.
Yay.
Genius.
Okay, and then take what you know and write that down. So start with what you know. Okay, so start with what you know, write that down. And then set up your first conversion. Okay, so I'm in the unit of mole. What unit am I trying to get to? Molecules. Do those things connect in one step? Yep, because of Avogadro's number. So, moles is here. So what should go down here? Moles.
Does the carbon and oxygen go down to
Yeah, so great question, Cam. So with the formula, now that we're getting into chemical themes, and once again, I know this is where some of you who hate writing have a lot of work, okay, it feels like a lot. But as these problems get more and more complex, labeling what you're talking about is super critical. Because we're going to soon be getting to chemical reactions where things are going to change into something new. So tracking, I'm in moles of this, moles of that same thing. Now, what am I trying to change it into?
molecules?
Good, so I'm trying to go to molecules. My abbreviation for a molecule is a cule. I made it up. You can't use mole because that's a thing, right? Okay, so I'm leaving moles, I'm going into molecules. What's gonna go here?
Is it
6.02 times by 10 to the 23rd
Top or bottom, Tate?
top?
Why?
Because that's 1 mole's worth. So you put 1 on the bottom and 6.02 on the top.
Yeah, make it into an equal statement, right? 1 mole equals this many molecules. If you put it on the bottom, you would have been saying that there's that many moles in 1 molecule, which, once again, doesn't make sense. Okay, questions on the setup, and then I'll show you how you can type this into your calculator. Okay, so there is a shortcut way to type in scientific notation on majority of calculators, which is really nice. If you've never learned this shortcut before, and if you don't know, I can show you where to find it if yours is different. So the way I would type this into my calculator is I would type in 2.50 multiply, because it's on the top, 6.02. Now if you have a graphing calculator, it's normally right above, it's a button that says EE in blue. It's normally above the comma on a graphing calculator. So if you hit second comma, if you have a graphing calculator, it will bring up a little capital E like this. Try that if you're using one of those. And then what this takes care of is the times 10. So all I have to write is 23. So for graphing calculators, did everyone find that shortcut button?
wait, I need to.
Yours is E. Yep. So yours is EXP. I'm gonna hold yours up. So if you have one like Cam, your shortcut is the EXP button. If you have one like Katie, yours is yours like hers?
Second.
Oh yeah, so right above the X -1. So, yeah, once again, you don't have to use the shortcut. You could type it in like times 10 power, but you have to then use parentheses. If you use the shortcut, you don't have to use parentheses because the E like bonds them together. So, would be the EX. So type 2.50 times 6.02, and then that, and then 23. And then enter. Yep, perfect. Okay, any other questions about how to type it in or where to find it? Yeah. Okay, what do we get for an answer here? 1.505. Now, there's 2 ways you could write your answer, and depending on your calculator, it might show it to you in one way. You could write how the calculator shows, where it says E to the 24, and then don't forget to label it, so fuels of this. Or this is the same thing as saying 1.505 times 10 to the 24. So both are the same thing. So. Questions on that? Okay, what I would like you to do is I want you to try example number 2. Once you think you have your work and answer, raise your hand, and if you're correct, then I'll give you the homework to get started on. And if you're not correct, then I'll help you out. Okay? All right, so try example number 2 as like your pass off, and then I'll pass out the homework to you. I think you used the wrong this guy. So that's a different one. So the one you want to use is times 10 to the x. start raising their hands, checking. So the biggest thing is, checking that their work is right. And then if their answers should be right. You can always double check it.
Let's start with what we don't.
So what I kind of look for, just for future, label that as moles. More than a thing, but not mole. So I always check that. Moles here. Go ahead.
Do we have to add the zero like that?
In terms of mathematically, it doesn't do anything, so. So yeah, so I check moles here, so moles there, so moles on top, and then make sure that Avogadro's get to label your answer. Does that make sense? Check that they have the right unit set up and that they put Avogadro's number in the right place, and then I guess the answer should be about 5.3 times 24. Sound good? Okay. Okay, yeah. Just label your answer. What's the answer now? No, just the times 10. What we want is times 10 and 100. You backtrack.
Oh, no, that's right. I'm wrong, equals 6.02 times 10 to the 23rd. And however you put it in your calculator, 8.90.
So it's just the first page after the icons is the homework for today. Front and back. I guess we can stop filming now.